Clostridioides difficile is a diarrheal infection that results from taking antibiotics used to treat other infections. And we rely on antibiotics a lot in hospitals, and as a result, C. diff is the leading pathogen that causes healthcare-associated infections and costs our healthcare system somewhere on the order of $5 billion a year. And we have antibiotics to treat C. diff, but an unacceptably large proportion of those patients will go on to have really serious complications of their infection. I'm talking up to a third of patients. I cannot tell which patients will go on to do fine with conventional treatment and which patients will go on to die of their infection. The premise of my project is that we can integrate our understanding of the host immune response to develop a panel of tests that, together with clinical factors, can stratify precisely which patients we should try new therapies or more aggressive treatment in order to prevent those outcomes that I talked about. Biomedical research has made many advances in recent decades with genomics, immunology, and clinical medicine. But as a result, both clinicians and researchers have become increasingly siloed in their areas of expertise. And what you really want is for every expert, for every component of a clinical problem in the same room, working towards applying a solution for that common goal. And I think it's really the utility of translational research to get those people in the same room and why it's so important. I think that the best scientific teams are those with just enough overlap of experience that each researcher feels excited to share their knowledge and contribute. I found myself at times feeling like an ambassador or an evangelist, talking to clinicians about how important it is that we bridge our understandings of basic sciences, and to researchers championing how critical their work is for benefiting real patients. And I think that's indicative of good team science.